Good evening everyone. Welcome to chemistry classes. Once again I'm back with another video where I will be continuing from where I did till last. Now in my last class, if you remember, I did atomic number, I did mass number, and also I have shown you that how electrons are distributed in the different shells. Today I'm going to do a few more examples where I stopped. So I will do the electronic configuration of a few elements. So last day I have shown you with sodium, but today I will be showing you with let's say nitrogen. Okay, so nitrogen, let me take another marker. So nitrogen, its symbol is N and its atomic number is 7, mass number is 14, right? So from this information, what do we get? We get number of protons. Protons, I'm writing it as P positive, okay? So number of protons will be how much? That is similar to the atomic number, 7. Number of electrons, how much will be this? This also will be similar to the atomic number, that is 7. And number of neutrons, N0, this one will be 7. So you can see I have found out all the three the data, that is the number of protons, the number of electrons and the number of neutrons. Now I will be drawing the electronic configuration. So for that, now there is another thing. Here there are two things. One is, that is the electron shell diagram. Now if you're asked to write the electron shell diagram, then if you remember, I was drawing the shells in the last class. I will be drawing that also, and there is another one, that is the Lewis structure, in which you only need to draw the electrons of the last shell. So I will be showing you both of them. First I am drawing the shell or orbital structure. So for this one, this is my nucleus. Over here there is proton 7, electron 7. Let me draw it a little bit bigger. So I think this is visible right now. Protons 7, neutrons 7. Now in the first orbit, that is the K shell, it will have 2 electrons. Since total number of electrons are 7, so first shell, that is the K shell, it can accommodate only 2 electrons. So 2 electrons I have given in the first shell. So how many are remaining? 5 electrons. So in the next L shell, it will be 5 electrons. 1, 2, 3, 4, 5. So total 7 electrons I have drawn over here. So this is my first orbital structure. Now Lewis structure I will show you. In this one, or also known as the electron dot diagram, electron dot structure. Okay, the Lewis structure or the electron dot structure. Okay, so for this one, how do we write it? We write the symbol of nitrogen right? And along with it, we draw the electrons of the last shell only. That is 1, 2, 3, 4, and 5. Now you know that the last shell is L shell, and L shell has only 5 electrons. So in the electron dot structure, we only draw for the last shell and not for the entire structure. Now one question might come in your mind, then what is the utility of drawing this structure? Well, the utility we will find in the following chapter, which is chemical bonding. Okay, in that particular chapter we will do a lot of things using this electron dot structure. Over there we will be using the the orbital structure, but that is very less and that is very limited. We will be using the Lewis dot structure over there. Next, another one I will be showing you, that is for calcium. Calcium, symbol Ca. It has atomic number how much? 20, and mass number 40. So you must be wondering that it's a huge diagram. Yes, it will be. So let me write down the number of P positive, number of E minus, and number of neutrons. Okay, so now that I have written all of them, I will be writing the numbers. So how much number of protons will be 20, because atomic number is 20, number of electrons will be 20, because atomic number is 20, and number of neutrons will be mass number minus atomic number, that is 20. Okay, so here I have written all my data. Now what I'm going to do is that I'm going to draw the orbital structure of calcium. I'm trying to draw it as big as possible. So here P will be 20, N will be 20. Now over here, as you see that there are 20 electrons and I will have to fit them in the different shells. If you want, you can use the 2n square. Okay, you can use the 2n square, that formula that I have given you in my last class, right? So using the 2n square, you can do it. I'm showing you how. For n equals to 1, it will be 2. For n equals to 2, it will be 8. For n equals to 3, it will be 18. But in this case, for n equals to 8, we accommodate how many electrons? Only 8 electrons. Right? And for n is equals to 4, we accommodate how many? 32. Here also, maximum we will take is 8. Okay, not more than that. Reason, again I'm repeating, it will be clarified in class 11 chapter of atomic structure. So for the time being, let us now come here. For the K shell, that is number 1, I will accommodate 2 electrons. My circle is not a perfect circle though, but yeah, still you can manage it. The second one, how much? 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Right? So in the next shell also I have given 8 electrons. Now that is, this one is K, this one is L. Next one comes is M. How many? Again 8. 1, 2, 3, 4, 5, 6, 7, and 8. And in the last shell, how many will go? So 2 I have given here, 8 I have given here, 8 also I have given here. So 8 plus 8 is 16, plus 2 is 18. So here it can hold 8 electrons, but I will give only 2 electrons because my number of electrons is 20. So in my last shell, I will be placing 2 electrons. So this is my orbital structure. This is my orbital structure of calcium. Many a times in the question papers of both ICSE and CBSE, you will find for 2 marks they give you for drawing this structure along with for solving these, for taking out these values. So this will be very helpful for all your question papers. Now let us begin our next topic, that is isotopes, another very important topic from which different types of questions comes. So what are isotopes? Isotopes are elements with similar atomic number but different mass number. Isotopes are elements with similar atomic number but different mass number. Now you must be wondering that how is that possible? Yes, it is possible. There are certain elements that are found which have similar atomic number but they have different mass number. Like for example, I'll giving you the example of the very basic one, that is oxygen. Oxygen has 3 isotopes. One is oxygen 08 and 16. This is the atomic number and this is the mass number. The next one is 08 17 and 08 18. What are you wondering? That whether this exists or not? Yes, it exists. It has been found in the earth, and that is the reason why the concept of isotopes came into the limelight. Well, when we will be doing the chapter of periodic table, probably this concept will be much more clearer as to why the periodic table took a long time in its journey to evolve as what we have the modern periodic table today. Because there were isotopes, and in the periodic table it is actually the isotopes that has been considered, calculating which we get the mass numbers that we find in the periodic table. Okay, so now giving you another example, that is chlorine, another very important one, chlorine, that is Cl 3517, Cl 3717. Okay, so these are the 2 examples that I have given you. Now you must be wondering that what exactly happens in an isotope, right? I have given you the examples, but what exactly happens? Why is it that the atomic number is same but the mass number is different? Because it is because of the difference in the number of neutrons. Okay, if you find in this one, for example, if I'm considering this particular example, or maybe this one, so what happens in for oxygen O16 8, I'm making it in the form of a chart. So here will be protons, electrons, neutrons. So for this one, protons will be 8, electrons will be 8, and the neutrons will be 8. O 17 8. So for this one, protons will be 8, electrons will be 8, but the number of neutrons will be 9. The next one, O 18 8. For this one, protons 8, electrons 8, but the number of neutrons will be 10. So it is because you see that the number of neutrons are changing, and that is why the mass number changes but the atomic number remains the same. So coming over here, if you have noted this down, I would just like to rub this and write a few important characteristics of the isotopes. Right? A few characteristics of the isotopes. Now, what are the characteristics? Characteristics. Number 1, Since the atomic number is same, number of electrons are same and protons are same, hence their chemical reactivity remains same. There is no difference in the chemical reactivity. Next one is same element with different number of neutrons. And number 3 is very rare in the Earth's crust, or in the Earth's crust, or maybe you can say surrounding. Because the isotopes are very rare in the Earth's crust, okay? It is not that it is found in a very large quantity, but yes, it is found. And that is the reason why we have calculated the mass number as an average of the as an average of the different mass numbers of the isotopes, okay? So this is the characteristics of the isotopes. Now finally, coming down to the last but very important topic, that is isobars. Questions do come from CBSE and ICSE board based on isobars. So what are isobars? Isobars are elements with similar mass number but different atomic number. You must be wondering that whether this is also possible, but yes, it is true. This is also possible. For example, a pair of elements that I will tell you is argon. Okay, argon. Argon has mass number 40, atomic number 18, and calcium, it has mass number 40, atomic number 20. Okay, so it is a pair of elements which are known as isobars. Okay, this is a very important question that comes in both ICSE and CBSE. So please do remember that though they have the similar mass number, but their atomic number is different. So coming down to the characteristics, you can understand that since they are both different elements, both are different elements, hence they will have different chemical reactivity. Already you know that argon, this happens to be a noble gas, that is, it is very, very inert and absolutely unreactive. On the other hand, calcium is another reactive element, you can say, because in the metal activity series, calcium stands in the 3rd place. So calcium is reactive. So both are different elements, hence they have different chemical reactivity. But over here, there is again another difference. That is the number of neutrons, they do change. Because over here, the number of neutrons is 20, but over here, the number of neutrons is 22. Okay, so in this pair, the number of neutrons, they are different. So differs by number of neutrons. So this is the one similarity that you can say that they that both of them have, that is the number of neutrons, they keep on changing. Okay, so this much for today's class. Thank you so much. I hope to see you all in my next class, and in my next class I will be starting another new chapter with some very basic concepts that probably you have not been told before and you have not been taught. So till then, prepare what I have done. Okay, stay home, stay safe, and stay prepared as always. Thank you so much.